Imagine a universe filled with billions of galaxies, each with millions of stars, and yet something invisible holds them all together. What could it be? Welcome to an astronomical adventure where we'll grapple with the unknown and dive into one of the most profound mysteries of the cosmos, dark matter. Though it remains unseen and undetectable by our most advanced scientific instruments, it's believed that dark matter makes up approximately 27% of the universe. That's more than a quarter. Just think about that for a moment. An invisible force silently shaping the universe as we know it. Its presence inferred only through its gravitational effects on visible matter. It's like a cosmic puppeteer pulling the strings of galaxies and stars, shaping the grand cosmic ballet that unfolds across the eons. This is the enigma of dark matter, a cosmic riddle that has puzzled scientists for decades. To understand the role of dark matter, one must first grasp the concept of gravity. This elusive force that keeps our feet firmly on the ground and the planets tethered in their celestial dance around the sun is a fundamental element of our universe. It's the invisible hand that shapes the cosmos, guiding the formation of stars, galaxies, and even the paths of light itself. Gravity, as Sir Isaac Newton first described, is a force of attraction that exists between any two masses, any two bodies, any two particles. It's what pulls the apple down from the tree and what keeps the moon in orbit around the Earth. But when we look out into the cosmos, we find that gravity has a far grander role to play. Consider our galaxy, the Milky Way. It's a swirling mass of billions of stars, gas, and dust, all spinning around a common center. According to the laws of physics, there must be a tremendous amount of mass within the galaxy to generate the gravity necessary to hold all these stars in their orbits. But here's the catch. When we tally up all the visible matter in the galaxy, the stars, the gas, the dust, we find that there's simply not enough of it. The gravitational pull of this visible matter alone is not sufficient to hold the galaxy together. So, what's keeping our galaxy, and indeed all galaxies, from flying apart? Well, scientists believe that there's a lot more matter out there that we can't see. It's not visible through our telescopes because it doesn't interact with light or any other form of electromagnetic radiation. We can't see it, touch it, or detect it directly in any way. Yet, we can observe its effects through its gravitational influence on visible matter. This mysterious invisible substance, this missing mass, is what we call dark matter. It's the phantom mass that exerts the extra gravity needed to keep galaxies from disintegrating. The gravity we observe suggests that there is a lot more matter out there than we can see. This unseen matter is what we call dark matter. The theory of dark matter is not a product of wild imagination, but a result of careful observation and calculation. Welcome to the fascinating realm of dark matter theory, where the unseen forces of the cosmos reveal themselves in the most subtle yet profound ways. Let's embark on this journey with the rotation of galaxies. When astronomers observe galaxies, they notice something peculiar. The stars at the edges of galaxies are moving at speeds that, according to the laws of physics, should send them flying into the cosmos. Yet they remain bound to the galaxy. The gravitational pull of the visible matter in the galaxy is simply not enough to keep these stars in check. So, what's keeping these wandering stars tethered? The answer, scientists believe, is dark matter. This invisible matter surrounds galaxies, creating a gravitational field strong enough to hold on to these speeding stars. It's like an invisible cosmic glue, holding galaxies together. Without it, galaxies would tear themselves apart, and the cosmic scenery we're familiar with would look vastly different. Now let's turn our gaze to a phenomenon known as gravitational lensing. When light from distant galaxies passes by an object with a strong gravitational field, it bends. This is much like how a lens bends light, hence the term gravitational lensing. Yet, the gravity of visible matter alone can't account for the degree of bending we observe. The culprit, once again, seems to be dark matter. This unseen substance, scattered across the cosmos, bends light in ways that only it can. It's like a cosmic magician, bending light with its invisible hands, further proof of its silent yet powerful presence. While we can't see dark matter, we can observe its effects. It's like feeling the wind on your face. You can't see it, but you know it's there. And just like the wind, dark matter, though unseen, has a profound impact on the universe around us. It is the invisible architect of the cosmos, silently shaping the universe in its subtle yet firm grip. Dark matter may be elusive, but its influence is undeniable. Imagine the universe as a grand cosmic ballet, with galaxies twirling gracefully in a dance choreographed by gravity. Now consider dark matter as the invisible hand guiding this celestial dance. It's the unseen puppeteer pulling the strings, directing the motion of galaxies and clusters across the vast cosmic stage. Dark matter, despite its ghostly nature, plays a pivotal role in the formation and structure of the universe. It's the silent architect, sketching the blueprint of the cosmos. From the smallest dwarf galaxies to the sprawling cosmic web of galaxy clusters, dark matter forms the skeletal framework upon which these structures are built. Think of dark matter as a cosmic glue. Just as glue holds together pieces of a puzzle, dark matter binds galaxies. Without it, galaxies would fly apart, their stars flung out into the vastness of space. The invisible grip of dark matter ensures that these celestial bodies remain intact, maintaining the harmony of the cosmic dance. Moreover, dark matter shapes the large-scale structure of the universe. It's like an unseen sculptor, molding the cosmos into its current form. Its gravitational influence pulls matter together, forming the intricate cosmic web of galaxies and galaxy clusters that we observe. Without dark matter, the universe as we know it would not exist. The invisible grip of dark matter is the silent force that holds our universe together, shaping its destiny in a dance as old as time itself. The quest to understand dark matter is one of the greatest adventures in modern astronomy. Scientists around the globe are racing to unravel this enigma, conducting groundbreaking experiments deep underground and in the farthest reaches of space. These endeavors seek to detect the elusive particles of dark matter, to grasp how they interact with our universe. As we continue to explore the cosmos, we inch closer to solving the dark matter mystery, revealing the invisible threads that weave the cosmic tapestry.